Here we are, continuing on down to trace the loads through our building. And again, let's just review what loads are given. We've already talked about the roof and the rafters. Let's look at this next layer down. So he tells us the live load is 40 pounds per square foot. What is the live load? That is things that come and go. So it's people, furniture, that sort of thing. Then looking at the floor, the dead load, that's the building itself. The dead load of the flooring is 5 pounds per square foot, and the joists add another 3 pounds per square foot. So we'll be using those momentarily. And here's where we left off last time. We had created free body diagrams of the front wall, the roof beam, and the back wall. And here they are with their numbers. And here's an exploded 3D view. Now we're going to move from here down to the joists. And again, just notice that the walls are at right angles to the joists. They're perpendicular. We're always turning 90 degrees when we go down a layer. Here is a joist. So we're looking down at the floor. There's a joist. And I call this an inside joist just because almost all of these joists carry a 2-foot wide tributary width. The ones on the outside, of course, carry half as much. So we're just going to look at our typical joist somewhere in the middle. And here's what it looks like. We've got the distributed load up above from the flooring, and then we've got a foundation at each end. There's those arrows, and we've got these posts and footings in the middle. Or here in the lower left corner of the slide, here's that joist with its 3 arrows. That's what we're talking about right now. Let's remember what we just looked at in the first slide, where he gives us the load, the live load, the dead load, the joists. The live load is 40. The dead load is 5 plus 3. So the total load on the floor is 48 pounds per square foot. But again, just like with the roof the other day, these joists are also 2 feet on center. So each joist carries a 2-foot wide strip of floor. What that means is this joist carries 2 square feet for every lineal foot of joist. So if the joist carries, if the load here is 48 pounds per square foot, the load on each joist is twice that, 96 pounds per lineal foot, because a lineal foot has 2 square feet of floor on top of it. Here's the start to a free body diagram of one of our joists. So we just found, let me back up, we just found that the distributed load on top of a joist, it's carrying a 2-foot wide strip, is 96 pounds per foot. So I've written that up above. Now we'll go find the reactions for the foundations and those posts underneath. We're looking for the foundations and the post underneath, which is actually carried by that middle floor beam. So we'll go back to tributary areas again. And here is the area over one joist that sits on that left foundation. Those joists are 2 feet apart, so it's got a tributary area that's 2 feet wide. And halfway between the foundation and the floor beam is 7 feet. So that tributary area must be what? 2 times 7, 14 feet, 14 square feet. And we just added up how much weight the floor has. Remember the live load, the dead load of the joist, and the dead load of the flooring, and we realized they added up to 48 pounds per square foot. So how much load is sitting on this left foundation? We've got an area of 14 square feet times 48 pounds per square foot. We must have 672 pounds sitting on that foundation. Now, how about this middle floor beam? Again, a 2-foot wide tributary width. Halfway between the floor beam and one foundation, halfway between the floor beam and the other foundation, gives us a tributary area here that is 13 feet wide. It's 2 feet deep. So what is the area in square feet of that tributary area? 2 times 13, that must be 26 square feet. And how much does it weigh? 26 square feet times 48 pounds per square foot. Punch that on your calculator and you'll get 1248 pounds. Now let's go to this right foundation. Here, halfway between the floor beam and the foundation is 6 feet, and it's still a 2-foot deep tributary width. So the area there must be 2 times 6, that must be 12 square feet, and it weighs 48 pounds per square foot. So this chunk of floor sitting on a joist, 12 times 48, must be 576 pounds. And now you can add those 3 numbers you just found to the free body diagram of the joist. So here in the bottom of the picture, here is our joist with our 3 support reactions. Here in the top is our free body diagram with a distributed load on top of 96 pounds per foot and our reactions underneath, 672, 1248, and 576. Okay, now we can draw a free body diagram of the left foundation itself. And it's got a distributed load on top from those joists, and it's got a distributed reaction on the bottom from the soil holding it up. Here's a sort of a 3D view with a repeat of the free body diagram of the joist that we just found, where, thinking about the ends, where the foundations are, we figured out that one foundation is holding up 672 pounds, and the other foundation is holding up 576 pounds. That's for a 2-foot wide strip, because recall that these joists are 2 feet apart, and so each joist is holding a 2-foot wide strip. If we want to boil that down to how much is happening on each foot of foundation, this might be familiar to you now, we've got to divide our load by 2. So if our joist sitting on our foundation delivers 672 pounds per 2 feet, if we divide 672 by 2, we must get 336 pounds for every 1 foot. So our left foundation, now hold on to your hat here, because we've got stuff from up above coming down on our foundation, don't we? Remember, we've been doing our roof and our wall, blah, blah, blah. So here's our left foundation. Earlier, in a previous slideshow, we figured out that the weight at the bottom of our front wall was 427 pounds. You might recall we did some math there. We added them up, and we found out 427 pounds at the bottom of the wall. Okay. Then just now, we figured out that those joists are distributing a load of 336 pounds per foot. So we've got the wall plus the joists, 427 for the wall plus 336 for the joists. We must have a total of 763 sitting on top of our foundation. There it is. And we've got an equal and opposite reaction underneath. Now we can do the same for the right foundation. That's this 576 over here. That's 576 for every 2 feet. What is it for every 1 foot? It's half as much. So every 1 foot has 288 pounds per foot. And on our right foundation, we've got the weight of the back wall, and here's our free body diagram from our back wall, where we figured out there was 262 pounds at the bottom of that wall, pounds per foot. So there's our 262 pounds per foot. Then we just now figured out that our joists are adding another 288 pounds per foot. So the wall and the joists together, 262 plus 288 equals 550. So we've got 550 coming down on this back foundation and 550 reaction pushing back up from the soil. I just want to point out, if you haven't already noticed, that our author is neglecting the weight of the concrete foundation. And that's a common thing that engineers do, especially when they're making a first rough pass through a structure. They'll say, the weight of the concrete is negligible. In other words, we will neglect the weight of the concrete. When we get to the very end, we'll go back and when we look at these footings, we'll say, well, what would happen if we added the weight in? And we will find out it doesn't really make much difference. So I just point that out. Let's stop here, and then we'll come back and look at that floor beam in the middle and what's happening with those posts.